you should take a few minutes, pause this video, and go ahead and try to find the length of each of these segments for these problems listed on this page. And once you've given that a try, then you can come back and start the video and we will go through all of these. So now that you have given this a try, let's go through these and see what we come up with. So here we have a line segment, and we can see here this is a horizontal line segment, and it's easy enough for us to just count the length of this. So this is 1, 2, 3, 4, 5. Okay, this has a length of 5 units. Okay. Another way to find that out is by looking at the coordinates here. So we can see the only coordinate that's changing is our x coordinate here. And so we go from -6 to -1. And so that's no different than saying -6 minus a -1, because that's how we're going to find the distance. We're going to take the difference between those. And since distance is always positive, we are going to put that in absolute value. So -6 minus a -1 is going to be -5. And the absolute value of -5 is 5. So that's how you do it computationally. Okay, here it's easy enough, we can count those. Same here with this vertical piece. Okay, we can simply count the difference, the distance between 1, 2, 3, 4, 5. This is also 5 units. Okay, and again, we can follow the same logic here, using just finding the difference between the coordinates. Notice just the y coordinates are changing. Okay, so I have 3 minus a -2. And so that is 3 plus 2, which is just 5. And the absolute value of 5 is 5. So again, that's how you do it computationally, though it's easy enough for us to look at these and see those. So let's move down here, and this becomes a little trickier. You can see now we have a slanted line, a diagonal line, and we can't just count distance because we're not only are we going horizontally, but we're also going vertically too. So let's look at this. We can figure out the distance this way, and we can figure out the distance this way. Okay, and now here we've created ourselves a right triangle. So this is 3 units from here to here, and this is 4 units from there to there. And so now this is a right triangle, and right triangles, if you recall, will fit the Pythagorean theorem, okay, which says that, so if you recall the Pythagorean theorem, says that a squared plus b squared equals c squared, okay, where these are the two shorter sides and c is the hypotenuse of the right triangle. Okay, so if we call this d, then we know that we can say that 3 squared plus 4 squared equals d squared. And so we can say 9 plus 16 equals d squared. And then come over here and we can say 25 equals d squared. and taking the square root of both sides, we can say that 5 equals d. So this is equal to 5. So this side here is equal to 5. And so we found that distance using the Pythagorean theorem. So now I encourage you to apply that. If you did not get these other two correct, you can apply that same logic to the next two examples, okay, to use the Pythagorean theorem to this problem and this problem. And so I will give you, if you want to stop and redo those, you should do that now. But let's move on to this problem here. Okay, so now we don't have grid squares to count. We're only given coordinates. We're only given ordered pairs. And so now we have to find a way, okay, to make this, how can we make this work in our Pythagorean theorem? Well, we can still form a right triangle. So that would still be a right triangle. We just need to figure out these pieces right here. This piece, this side right here, the length of this side, notice that if you think back to our horizontal line, only the x values change. So this is going to be the difference in your x values. Okay, so this distance right here is going to be 20 minus 4. That distance here is 20 minus 4. And this distance here is going to be the change in our y values. Okay, so this distance is going to be 31 minus 15, the absolute value of that. It's nice and big. So now we can use that to find the side lengths. Okay, so 20 minus 4 is 16, and 31 minus 15 is also 16. And so now this value d, if we want to find that, we know that 16 squared plus 16 squared is equal to d squared. And so now we can just use our calculator and solve for that. And so we get 16 squared plus 16 squared is 512. That's equal to d squared. And then we can take the square root of that. And so d is equal to square root of 512, which is about 22.63.